Hi friend, in this session we will see the properties of determinants. We have basically 9 properties are there for solving out the determinant. The first property, you see, if each constituent in any row or column is 0, then the value of determinant is 0. Now I explain you how to solve this. Determinant A is 0, 0, 0, 9, -4, 2, 3, 1, 7. Now we have to find the value of this determinant. So what we will do, first we have to put A11, the value for any determinant, because we know the formula for the value of determinant. The value of determinant is equal to A11 M11 minus A12 M12 plus A13 M13. This we know in our previous session in determinant 2. We know this all about how we get the negative and the positive sign over there. So the same formula we are applying here. A11 is 0 and M11 is -4 to 17. Is it clear? Minus this also 0, A12, and we have to put here 9, 2, 3, 7, and then 0, 9, -4, 3, 1. Now look at this. 0, -28, -2, the main diagonal we will product of the main diagonal we will take, then it subtract the product of half diagonal from this main diagonal. So -0, it is 63, -6, this 0 again, 9 plus 12. So look at this. 0 multiplied by -30 is 0 multiplied by 57 plus 0 multiplied by 21. So we get all zeros here. 0, if we multiply 0 with any quantity, we get 0 minus 0 plus 0. So we get 0. So this property we have verified here. If each constituent in any row or column is 0, then the value of determinants is also 0. Now we see second property. Now we take another example. Now we see the second property of determinant. The value of determinant is not altered by changing its row into columns or columns into row. So let us take one example for this. Okay, so we have a determinant A. 3, 14 -572 6 7 9 is the determinant we have. We have to find out the value of this first. So we get the value in this way. 3 7 2 7 9 -1 -5 2 6 9 plus 4 -5 7 6 7. Now we simplify this. 3 7 into 9 63 minus 14 minus 1 minus 45 minus 12 plus 4 minus 35 minus 42. Now we simplify this. 3, 9, 49 it is, minus 1 minus 67. So it is 57 here. Plus 4, it is minus 777. Okay. 147 it is plus 57, it is minus 308. Now look at this. If you simplify this, minus 308. So now we get now we get the value of this determinant is minus 104. Minus 104 is the value of this determinant. Now, as per this property, we see the value of determinant is not altered by changing its rows into columns or columns into row. Now we change first row into column and column into row. We change this rows into column and column into row. So we get a new determinant, the other form of determinant here. A, we change row into column and column into row. Let us see. 3 minus 1 4, which is in row, we put down in column now. So 3 1 4 we write in a column form. 3 1 4. Now the second row we also put in a column form. Minus 5 7 2. This minus 5 7 2, and the third row we also convert into column. 6 7 9. It is 6 7 9. Now we find out the value of the determinant of this. We evaluate this determinant. So we get here 3. We have to leave this row and this column and put down the elements of n minus or 3 minus 1, I mean 2 by 2 determinant. 7 7 2 9. Now we take second symbol is negative, but it is minus 5. We have to put here. Then 1 7 4 9. Positive sign, we have to take the alternate sign convention. We have to apply here. Here is 6 1 7 4 2 6. This one we have to put this one. Now we simplify this. We get 3 9 into 7. This is the diagonal. 7 9 63 minus 7 into 2 is 14. Minus minus plus 5. We get 9 1 times 9 and 7 4 times 28. Then plus 6 2 into 1 2. Then minus 7 4 28. So we get here now is equal to 3. 13 minus 4 9 and 5 minus 1 4. It is 49. It is plus 5. 9 minus 28, it is 19. It is negative 9 because the 28 is a major number. Here we get 6 into minus 26. Now get here 3 into 49, 9 3 27, 2 carry, 4 12, 147. It is now minus 95. It is now minus 6 6 36, 3 carry, 6 to 12, 156 now. We get here now 147 minus the same signs, we add these up. It is 11, 1 carry, 5, 9, 14, 115, 1 carry, 251 now. So we subtract this, we get here 11 minus 7, which is 4. It is 4 minus 4, which is 0, and 2 minus 1, which is 1. Or a greater number has negative sign, so we get minus 104. So now we have proved this property that the value of determinant is not altered by changing its row into columns and columns into row. So this we have got the same value, minus 104 and minus 104. Let us see the third property of determinant. Now let us see property 3. If two adjacent rows or columns of a determinant are interchanged, the determinant changes in sign, but its numerical value is unaltered. So we have taken the determinant in property 2. The same thing we are taking here, determinant A. We have 1, 2, 3, minus 4, 0, 9, 7, 3, 5. This is the determinant. Once you find the value of this determinant, what would the value of this determinant should be? So we get here determinant of A, we expand this. So it is from the first row we are expanding this to first row. So it is 1, then 0, 9, 3, 5, 0, 9, 3, 5. We know how to expand this. The second sign would be negative for 2, minus 2, and here minus 4, 9, 7, 5. And we take again positive sign, which is 3, and minus 4, 0, 7, 3. This we have got. Now we simplify this, just 1, 0 minus 27, minus 2, minus 20, minus 63, plus 3, minus 12, minus 0. You get here minus 27, you get here minus 2, minus 83 here, we get here 3 multiplied by minus 12. So get here minus 27 plus 166 minus 36. So get the value here, get the complete value, minus 27 plus 166 minus 36. So you get here 103, which is positive. 103 is the value of this determinant. Now I interchange any row or the column. So I interchange column here, interchange column 1 and 2. 203 I put first. Determinant A 203 is the second column I am putting as the first column here. 1 minus 4 7, 1 minus 4 7, it is the first column we are putting in the place of second, and 395 as it is. 395. Now we expand this, what happens we see. So determinant of A would be 2 minus 4975, then negative 1, 0, 9, 3, 5, then positive 3, 0, minus 4, 3, 7. Now we simplify this, so we get here 2 minus 4 into 5 minus 20, negative sign we have to take from our side, it is 63, 79, 63 minus 1, 0 minus 27 plus 3, 0, negative minus square minus minus here plus 12 now. So we get here 2 multiplied by minus 83 minus 1 into minus 27 plus 3 into 12. So get here minus 166 plus 27 plus 3 into 12, 36. So get here minus 166 plus 7, 6, 13, 1 carry, it is 63 now. So we subtract this, the difference sign, the negative sign we will put here because the great number has negative sign. 6 minus 3, 3, 6 minus 6, 0 and 1. So it is negative 103. So you look at this. Here we get the negative value and here we get the positive value. So look at the property now. Two adjacent rows or columns of a determinant are interchanged. The determinant changes in sign but its numerical value is unaltered. So this we have got here now. Now look at now we see property 4. If two rows or columns of a determinant are identical, then the value of the determinant is 0. Now with determinant A we have 1, 2, 3 minus 4, 2, 7, then 1, 2, 3. Here you see the row 1 and the row 3 are identical, or if we expand it we get 0 or not. We see here, we verify this, expand this to first row, so 1 and 2, 7, 2, 7, 2, 3, the element of first row, accepting the element first row and first column. The second we have to put the negative sign for 2, it is 2 minus 4, 7, 1, 3 minus 4, 7, 1, 3. Now I have 3, 4 positive, minus 4, 2, 1, 2, minus 4, 2, 1, 2. Let's see what happens. Here 3, 2 times 6 minus 14, it is minus 12 minus 7, it is minus 8 minus 2. So get here 1 into 14 minus 6 minus 8 minus 2 multiplied by minus 19 plus 3 multiplied by minus 10. So we get here minus 8, we get here minus plus 38, and here we get minus 30. So you see here, we get here 30 minus 30, which is equal to 0. So this property we have proved that if two rows or columns are identical, the value of the determinant would be 0. If all the elements of a row or column of a determinant are multiplied by a constant k, then the value of determinant gets multiplied by that constant. So let us take an example. Here we see a determinant A. We have 1, 4, 3, minus 2, 3, 7, 6, 5, 8. This we have, or we are multiplying here the second column with a constant 2. Multiplying column 2 by 2. To get here, what happens? We see the first column as it is, second column we are multiplied by 2, 4 into 2, 3 into 2, 5 into 2. Third as it is, put it the same. Now we see what happens. 1 minus 2, 6, it is 8, it is 6, it is 10, it is 3, 7, 8. Let us see. We simplify these determinants. The first we simplify this determinant. We get here, I put directly 1, 3 into 7, 3, add 24 minus 35 minus 4. From first row we are expanding it, so it is minus 16, then minus 7642. Here is plus 3 minus 10 minus 63 again. Okay, so I get the expansion of this. It is minus 11, 24 minus 35. It is minus 4 into minus 58 plus 3 into minus 28. So get here minus 11 plus 232. Here we get negative 3 times 24, 2 carry, 3 2 6, so 2 8 minus 84. So you get here now 232 minus my 95. So get now finally 12 minus 5 7, and here 12 minus 9 3, and here 1. That is 137 we have got. Now this is 137 we have got. Now we expand this one. So I simply expand this also here. I change the color here. So we get 1 multiplied 6 into 8 and 648 minus 70. Second sign negative for 8 minus 2 into 8 minus 16 minus 7642. Here we get 3 and minus 2 into 10 minus 20, 6 into 6 minus 36. We got this. So now 10 minus 2 and 6 minus 4 2. It is minus 22. Where the negative sign have greater number have negative sign, minus 8 into this negative 58. Okay, here 3, get here minus 56. Now we simplify this, minus 22 minus minus plus 8 is 64, 6 carry 8 by 40, and 6 it is 46. Now here we get the negative sign. 6 3 times 19, 1 carries 15, 116, 168. To get here 464 minus 268, 01, 628, 19, 190. So get here 4, 16 minus 9, 7, and 3 minus 1, 274. So you see it is 274 is 2 times of this value 137. It is 2 times of 137, 274. Okay, so we have proved this one. We have proved this one. So the value we get here, you could say that it is the determinant A. So it is the 2 into determinant A. The value of determinant A is 137. So we double the value, that we have multiplied by 2 column second. So in this way we have proved this property. If all the elements of a row of a or column of a determinant are multiplied by a constant, then the value of determinant gets multiplied by the same constant. Okay, now we see property 6. If each constituent in any row or column consists of 2 terms, then the determinant can be expressed as the sum of 2 determinants of the same order. So we see, we take an example for this. Determinant A is 1, 4, 3, 7, 8, minus 2, 9, 5. This we have. First we find out the value of this determinant. We see what happens. It is 1. So we have, I explain in detail also. 7, 8. Remaining first column, we have to take the elements. Now minus 4, 4, 8, minus 2, 5. 4, 8, minus 2, 5. Now plus 3, 4, 7, minus 2, 9. Now simplify this. 1, 7, 5 times 35, 9, 8 times 72, minus 4, 4, 5 times 20, minus plus 8, 2 times 16, 3, 9, 4 times 36, minus plus 7, 2 times 14. So we get here 12 minus 5, 7. 12 minus 35 minus 72. 35 minus 72, we get here minus 37. Minus 4, we get here 36. 3, we get here 50. So we get here minus 37 minus 144. And here 150. So we get here 181 minus 181 plus 150. We get here minus 31. So this value we have got here. The value of this determinant. Now I split the middle column of this. Look at this, I change first color. I split the middle column, determinant of A for this. I split the middle column. First column I put as it is. It is 1 plus 3. It is 2 plus 5 and it is 4 plus 5. I write in this way. The middle column we have split it is 3, 8, 5. We see, we distribute this now. We distribute it in this way. We can write 1, 4, minus 2, 1, 2, 4. The first term we are writing here only of the second from the second column, and the third column as it is we have 3, 8, 5. The first column same and third column same, and the second column we have put the first term plus, because there is a positive sign between them. So we put here positive sign. So the first column same 1, 4, minus 2. In the second column we put down the second term now. 3, 5, 5, and in the second column we put the second term 3, 5, 5, 3, 8, 5. The third column would be same. So let us see what happens. We find out the value of this. Value of first we sort out. The value of first is this one. I am writing down here with a different color. 1, 4, minus 2, 1, 2, 4, 3, 8, 5. We expand this. 1, 2, 8, 4, 5, minus 1, 4, 8, minus 2, 5, 3, 4, 2, minus 2, 4. I expand this. Yeah. So here we get 1, 10, minus 32, minus 1, 20, plus 16, minus will be positive here, 3, 16 plus 4. So that here minus 22, minus 1 into 36, plus 3 into 20. So get here minus 22, minus 36, plus 16. We get here minus 58 plus 16. So we get here 2 value. This is the value of this determinant, the first determinant value we are getting 2. And the whole determinant value, we know that it is minus 31. I find out the value of the second. This determinant value we have to find out 1, 4, minus 2, 3, 5, 5. So I write down with a different color. 1, 4, minus 2, 3, 5, 5, and third column is same 3, 8, 5. So we see what happens now. 1, 5, 8, 5, 5, minus 3, 4, 8, minus 2, 5, plus 3, 4, 5, minus 2, 5. Now we simplify this. What happens we see? 1, it is 25, minus 40, minus 3, it is 20, plus 16, plus 3, it is 20, plus 10. We get here minus 15, we get here 3 into 36, we get here 3 into 30. What happens we see now? Minus 15 minus 3 into 36. We get here 108 now, and here 90. So let us see what happens. Now let us see what happens here. So it is equal to minus 15 minus 108, then plus 1. Get here minus 33. It is minus 33 and this is 2. So this is the value of the second determinant. We have got minus 33 and minus 33, 2 minus 33, we get here 2 minus 33, we get minus 31, which was the value of our original determinant. We have got the value minus 31, and the value of this determinant is 2, and value of this is minus 33, and value of this determinant is minus 31. So all things are equal now. If we put here positive sign, plus, minus, minus, we get the same thing. So now we have verified this problem, this property, sorry. If each constituent of any row or column consists of 2 terms, so we have divided the middle column in 2 terms. Terms would be with the positive negative sign. Then the determinant can be expressed as the sum of 2 determinants of the same order. So we have taken the sum of the 2 determinants of the same order as the 3 by 3 order of the both the determinant. We have put the first term of column second, the first determinant, the second term in the second determinant, the remaining columns are same. So in this way you could easily verify or prove this sort of. Now we see the property 7. If the element of a row or column of a determinant be added or subtracted, the equimultiples of the corresponding elements of one or more rows or columns, the determinant remains unaltered. So first let us take an example for this. So the color, we start with determinant. We take an example. We have 1, 2, minus 1, 4, 3, 6, 2, 3, 5. This we have. Now this one is C1, C2, C3. This is R1, R2 and R3. Row 1, row 2, row 3, column 1, column 2, column 3. So what we do C1 tends to 2 into C1 tends to C1 plus 2 into C3. We are multiplying C3 column with 2 and we add with the 1. We see what happens. For this, first of all, we find out the value of this determinant. So the value of this determinant, we see what happens. So I put the value of this determinant here. 1, 3, 3, 6, 5, 3, 3, 6, 5 here, minus 4, 2, 3, minus 1, 5, 2, 3, minus 1, 5, plus 2, 2, 3, minus 1, 6. Yeah. Now we simplify this. What happens? 1, 3 into 5, 15, minus 18, minus 4, 10 plus 3, plus 2, 12 plus 3. This is what happens. It is minus 3, minus 4 into 13, plus 2 into 15. So we see what happens now. Minus 3, minus 52, plus 30. So it is minus 55 plus 30. So it is minus 25 now. Okay. So we have the value of this determinant is minus 25. Now we do this process here. In this determinant, we do the same thing. Determinant A is now would be first row 1 adding C1 plus 2 into C3, 2 into C3, 2 to the 2 into the 4. The second column will be the same, third would be the same. 2 plus 6, 2 times 6, 3, 3, it will remain same. Minus 1 plus 5, 2 times 10, it is 6, it is 5, it will be same. Now if what happens, I change the color here. Here we see it is 5, it is 8, it is 9, it is 4, 3, 6, 2, 3, 5. Now expand this. See what happens. It is 5, 3, 3, 6, 5, 3, 3, 6, 5. Now minus 4, 8, 3, 9, 5, 8, 3, 9, 5, plus 2, it is 8, 3, 9, 6, 8, 3, 9, 6. Got this. Now 5, it is 15 minus 18, 4, it is 40 minus 27, plus 2, it is 48 minus 27. You get here 5 into minus 3 minus 4, 13 plus 2, 8 minus 7, 1, 4 minus 2, 2, 21. It is minus 15 minus 52 plus 42. You get here minus 67 now plus 42. Look at this, 7 minus 5 and 6 minus 4, 2. The greater sign has negative, greater number has negative sign, so you get minus 25. So look at this, minus 25. This one is minus 25. This one is minus 25. Value will unaltered. Now I explain again this theorem, statement of this theorem. If each element of a row or a column of a determinant be added or subtract the equimultiples of a corresponding elements of one or more rows or columns, the determinant remains unaltered. The determinant is unaltered. The value is same, minus 25, minus 25. Now, see the property A, the fact which is called the factor theorem. If the elements of a determinant involving x are polynomials in x, and determinant is equal to 0. When a is put for x, then x tends to a is a factor of this determinant value. So we take an example for this. Take a determinant x 3, 7, 2, x 2, 7, 6, x. Now we expand this with first row x, x2, 6x minus 3, we get 2, 2, 7x, 2, 2, 7x. This column and this row we have to give, and 7 for 7, this column, this row, 2x, 7, 6. Which what happens now? It is x square minus 12, and this determinant is equal to 0. They are asking that this determinant value is equal to 0. We put to letter this thing. First we see this, minus 3 is 2x minus 14 plus 7, 12 minus 7x. Because we know that the determinant value is equal to 0. It is a condition there, the determinant is equal to 0. So we put this value is equal to 0, and first we simplify this, then get 0 here, and it is x cubed minus 12x, it is minus 6x plus 14, 42, 4 into 3, 42 plus 14, 12, 7, 84. It is 84 now. It is 49x. It is x cubed minus 12x minus 6x minus 49x. So it is 12, 6 and 49. So you get here minus 67x, and get the value constant there, 6 and 4, 12, 126. And we are marking is equal to 0. The determinant is equal to 0. We would put here determinant and we put here 0. Okay. So we get x tends to a would be the factor of this. So we find out the factor of this x cubed, and 126 is there. So if we put then it may be roots like that. If we simplify this, we get here x plus 9 then x plus 9, x minus 2 and x minus 7 would be the factor of this. So if x tends to 9 and minus x tends to minus 9 and x tends to 2 and x tends to 7, so this would be, in this way we could find out the factor. Please call the factor theorem. In this way we could find it easily. You simplify this, you get this factors over there. Now we see the last property, property number 9. The sum of the product of cofactors of a particular row or column and any other row or column of a determinant is 0. So let us take an example for this. So we have a determinant A 1, 3, 5, 2, minus 2, 7, 0, 4, 6. We have this. First we see, find out the cofactors C11. We know that the cofactor Cij, I is the row, I mentioned the number of row and j is the number of column. It is minus 1 power I plus j or Mij. This formula we have to use here. Now we see C11. Living first column and first row we get minus 2, 7, 4, 6, which is equal to minus 12 minus 28, which is equal to minus 40. Now C12, it is the odd number. So if we get the odd number in power, we get negative sign here. I am putting in a negative sign already. So it is 2706. 2706 being first row and second column. You get here 12 minus 0. It is minus 12 now. And C13, you get here for the design where the sum is even. 2 minus 2, 0, 4. 2 minus 2, 0, 4. So you get here 8. 0. So it is 8 now. This C21, it is negative again because the sum is odd. So you get here C21 3, 5, 4, 6. 3, 5. In C21 we get negative sign here, and 3, 5, 4, 6 we get here. We get here negative. 6 3 times 18 and 4 5 times 20. We get here 2. Minus 2 plus 2. Minus minus plus. We get here C22 is the even numbers. We have to get the positive sign here. We get 2 to 1 5 0 6. 1 5 0 6. So we get here 6 minus 0, which is 6. C23, get here negative sign because the sum is over here again. So get 2 3 1 3 0 4. 1 3 0 4. We get here minus 4 minus 0, which is minus 4. Now C31. It is even. We have to get the positive sign here. C1. 3 5 minus 2 7. 3 5 minus 2 7. 3 5 minus 2 7. So we get here 21 minus minus plus 10. So it is 31. See 3 2. It is odd now. 3 plus 2 is 5, which is odd. So we have to get the negative sign here. 3 2. 1 5 2 7. It is 1 5 2 7. To get here negative 7 minus 10. It is C33, which is even, we have to get it positive. 33, 132 minus 2. 132 minus 2. We get here minus 2 minus 6, which is minus 8. So we got these all cofactors here. Now we know that if you have to find out the value of any determinant, we multiply the cofactors with the corresponding elements. Now here what we do, we see what I am doing here. A11 I am multiplying with A12. A21. And A12 I am multiplying by A22. C22. And A13 I am multiplying C2. So we see what happens here. So A11 is the first element. First element we have 1, second is 3 and 5. 1, 3, 5. Here I put 1. I change first color. 1. Here 3. Here 5. And C21, C22 and C23 we have to put here. C21. 2, 2, 2, 6 minus 1. 2, 6 minus 1. 2, 1, 2, 2, 2, 3. 2, 6 minus 4. 2, 6 minus 4. We get here 2. We get here 18. We get here minus 20. So 20 minus 20 is become 0. So you see here, as per this property, the sum of the product of cofactors of particular row or column, any other row or column of a determinant is 0. The determinant is always 0 if we multiply with other corresponding rows or columns. So you get always 0. So these were the 9 properties of determinants we have seen in this